Now, when we're looking at simple interest versus compound interest, we're now going to look at loan. Okay, so let's have a bit of a recap between simple interest and compound interest. We can see that in both cases we started with a loan of 10,000. So we started with 10,000 across here, straight across here. So that's our V0, and at V0 the principal stays the same the whole time. And simple interest, we could see we're just constantly adding this little amount called D, but on the compound interest we're multiplying and we're getting a much steeper thing. So we're going for a straight line here, and here we're going for a curve. And we developed a recursion formula. So both of this is a recursive formula for simple interest, and this is a recursive formula for compound. But we also found that we could also make another kind of formula, which is just like a rule, just if you want to go straight to term 10. Or here's the compound interest version if you want to go straight to term 10. Now, in both of these cases, we're actually like more looking at an investment. Say like you've put $10,000 in the bank and the bank is giving you interest, so now your money is going up in value. But if we wanted a loan, which is like instead of giving money to the bank, we're actually getting money from the bank. We don't want it to keep growing exponentially. We don't, or even linearly. We want our value to go down to zero, right? So we want eventually, like the $10,000 that we borrowed from the bank, we want to give them back enough money so eventually it hits zero at the last time period. So let's zoom in on compound interest. Again, we can see that the graph tends to do this, but we want the graph to actually do this, which means when we start with $10,000, let's just highlight the first payment here. And you can see this part, remember, that's how much interest you owe. So that's the interest, right, at the end of the first year. So you need the value to go down. Therefore, you need to pay back more than the interest. So you want this to go down a little bit each time. So the interest in this case was $1,200. So if you make a repayment greater than $1,200, then you're going to start eating into this part. You're going to take a little nibble off your principal. So your principal will get smaller. And so next time we calculate interest, instead of the interest going up, the interest will actually be smaller because you're actually calculating it off a smaller height each time. So it's getting smaller and smaller. So that's why you'll get a sort of curving down rather than that horrible curving up. So we need to look at that formula where we say, okay, the next term equals a ratio times the previous term. That was the formula we had before. But we need to make a payment to the bank. Now, if you're giving money to the bank, that's a negative for you because the money is going away from you. It's going to minus a difference here. And that difference needs to be bigger. So in this case, if we look at this, the RVN is 1,200. If I minus more than 1,200, in this case I'm saying $17,084, then I can see that actually my next term is going to be smaller. So each term is getting smaller and smaller and smaller. So we get a shrinking effect down to that zero, which we want. Okay, so we're at 10,000 at zero, and at time 10 we go zero money, which is what you want to do. So we want that curve down that says our loan is shrinking. So you can see we borrowed 10,000 for 10 years. That could be a simple loan or a second hand payments. Now, payments per year, that's how often you give money to the bank, known as PY, is just one. We're going to keep it nice and simple. And our compounding per year, so compound per year, that's how often the bank sits down and actually calculates the interest on your loan. That's CY, that's also going to equal 1. So PY and CY, that's what they mean. You do your financial solver later. And we just did the interest rate equals 12% PA. And because it's per annum, it works out nicely with the ones for the payments and the compoundings. So we know that normally with a compound interest, you have this idea that Bn plus 1 equals RVN. But we also wanted to reduce this loan. It's called a reducing balance loan. We want to subtract an amount, subtract a D. Now, let's just remind ourselves, big R, because this is little r, big R equals 1 plus little r over 100. So this equals 1.12. And I've done this on the calculator to get the D is $1,769.84. Okay, so we can put those in there. So that's 1.12 times the previous term minus $1,769.84. And if you remember, the very first term, when we were doing formulas growing up, that the first amount of interest, if you do 1.12 times 10,000, you get 1,200. So you can see that this is the interest part. That's the interest amount. It's in dollars. The maximum is going to be is 1,200, and this is your repayments. This is your repayments. And so as long as the repayments is more than the interest amount, your loan reduces in value. That's why it's called a reducing balance loan. So here is our loan, and it's reducing down. I've just added a couple more. This is the balance of the loan. So that's the bit you still owe. So you still owe this amount. And then hopefully that gets down to 0 in your 10th year. But what I've also done is I've added this line. And that's your repayment. In this case, it was $1,769.84. And that's constant. You can see it's a straight line across, it's constant. And if you look here, this green part represents the interest we paid. So that's the interest amount. And you can see that that's actually reducing because the interest is calculated on the balance. So if the balance is going down, then the interest is going down. And so the difference between the payment and the interest, this gap here, the little gap here, and you can see that gap's getting bigger, until basically the last repayment is just paying off principal, which is the balance still owing, the blue part, and there's no interest to pay at all almost. So they completely, the interest has disappeared, and the last repayment, it's a bit hard to see, you're basically paying off the blue part. So this orange is what we call the principal reduction, because that's how much has gone down from there, and then it's going down from there, and it's going down from there, and that's where it's going. That's how much this is going down, and you can see that starts to accelerate. And that's what's great about a home loan, that it really accelerates as we go down. So at the beginning, yeah, the term 1, you can see that the green part makes up most of your repayment. So most of what you're repaying is interest. Whereas in the middle part here, kind of we're going, okay, well, actually, most of the repayment is now going on actually principal reduction rather than the amount of interest, until the final payment is almost all just getting rid of the principal and not the interest. And that's how a loan progresses. If you were actually doing a mortgage, you're probably making about 780 payments. It actually haven't mentioned 780 columns. It can be quite depressing when you first get your mortgage and realize that the principal reduction is very, very tiny, because you're almost entirely paying off the interest. So your principal reduction can be quite tiny, and it's later on in your loan that you get actually reducing how much you still owe the bank. Okay, so this is an amortization table. It's called that because it's often used for mortgages, mortgage, amortization. You can see the connection in those words. Now this is just simply the table of the graph I showed before. So remember, this is the amount paid. I gave that in red. and the interest paid I said was green, and the principal reduction was the orange. Okay, and we know that the balance still owing. Don't do that. I'm just going to surround it. Now we need to look at some of the relationships on these tables, because often you get a question like, what's this value, or what's this missing value, or what's this missing value, or what's this missing value. And these are very common questions on SATs and exams. So to know the relationships between these columns is very useful. Now, some of them are easy and some of them are a little bit harder. It depends what information you've got, how to work them out. The first one to think about is quite easy. Now, we know that the formula is going to be n plus 1 equals RBN plus D. Now, this is a loan and we're making repayments, so we're giving money to the bank, so we make that a minus. And that's basically the D is the amount paid. And if you look down the trend, what you notice stays the same. So the D is a constant in all of these situations. Let's look at the next column, interest paid. Now, interest paid has that lovely formula R equals 1 plus R over 100. Now, we just need to focus on this part, because that's the interest part. The other part, the 1, represents the balance of the loan. So we only want the interest paid. So interest paid is this is just R over 100 times the previous one. Okay, so we might as well just be in. And so if you take the 10,000 and times that by 12 over 100, you'll get your 1,200. And then you take the 9,430 and do the same thing times 12 over 100. Notice it's going down a row, so the 10,000 gives you the previous amount. It is what you calculate the interest off. And so it just keeps going that way, down a row, the whole way down. Let's just emphasize that by drawing lots of arrows, which I'm going to do in a second. You can see we're all going down like this. Now, as the balance of the loan is reducing, therefore the interest you're paying is reducing. So if you look at the trend down this column, it's reducing, which is what you want to do, and pay less and less interest along the way. So that shows the relationship between the balance and the interest rate, because the interest rate was 12%, if you remember. The next one I'm going to look at is principal reduction. I've actually said this on the previous video. If I take the red amount minus the green amount, it equals the principal reduction. So there's a number of ways to look at this. So the amount paid, I'm going to call it PMT, because that's what it's going to be called on your financial solver, minus the interest paid, right, which is going to say I, call it I, equals the principal reduction. So put that in a nice green box to emphasize a new formula for you, just the same way this is a nice little formula for you for the interest paid. And make sure the interest equals that. And what you'll find is that it's just simply this number minus this number equals this number. And that's the whole way down. It's like that. So this number minus this number equals this number, and so on. This number minus this number equals this number. And that's all you have to do the whole way down. Now, let me just clear all that up, so we don't get too messy later on, because we've got to do some more work on this. So our trend here is the principal reduction is actually reducing. Okay? You can do this in reverse, and you can rearrange those formulas. So you might think that the payments minus the principal reduction can get you the interest. That's another way to calculate the interest. So there's more than one way to get the interest on this. But principal reduction is going up because the interest is going down, because the total of these two added together equal that one. All right, that's just the same formula as I've done on the left-hand side here. It's just rearranged. Okay. All right. Now the last one to look at is the balance of the loan. Now the balance of the loan is you take this value, you subtract the principal reduction, because basically that's what the balance of the loan is, the principal, minus that one, and it'll equal this one. Okay. So quite easy to see. What you're doing is just basically zigzagging your way down here. So you zigzag like this. Your minus and that equals, your minus and equals. So just subtracting your way down, zigzag, 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 zigzag. And you might just end up with like little 3 cents. I mean, the bank will ask you for that. And whoever missed the money. So sometimes you might actually have to increase the last payment just to cover that last 3 cents. So the payment over here, you might have to change that to $1,769.87 just to make sure that that 3 cents also disappears. So if we look at this and write this out as a formula, we could say that the balance, let's just rewrite that properly. Try that again. So the balance equals the previous balance minus the principal reduction. And that's how you calculate all these things. Notice eventually your loan always gets down to here. This is called, these might be called your final, the final value. You want a final value of 0. Okay.